Hi dear students, in this session let us discuss Ampere's circuital law, and this Ampere circuital law is generally used to determine the magnetic field of what? Current carrying conductor. You know very well, as per the definition of what? The magnetic effect of electric current. If we consider any conductor in which current is flowing in the surrounding space of what? That conductor, definitely the magnetic field is going to produce. The strength of the magnetic field produced at any point due to the current carrying wire or current carrying conductor can be easily estimated with the help of what? The Ampere's circuital law. So far we discussed Biot-Savart law, and you know very well the Biot-Savart law is used to determine the magnetic field produced by small part of a conductor, but the Ampere circuital law is generally used to determine the magnetic field produced by what? Entire conductor. Generally the magnetic field produced by entire conductor can be determined with the help of what? The Ampere's circuital law. So take down the next title here, Ampere's circuital law. Ampere's circuital law. So in this class, using Ampere circuital law, we'll try to estimate the magnetic field produced by infinitely long current carrying conductor. I will consider a conductor of what? Infinite length, in which current I is flowing, and due to that current or due to that current carrying conductor, there exists a magnetic field, and we'll try to estimate that magnetic field with help of what? The Ampere circuital law. At the same time we'll try to understand what is the statement of what? The Ampere's circuital law. Suppose if we consider any current carrying conductor, say for example I is a current which is flowing through the conductor, and this conductor is going to produce the magnetic field. This conductor is going to produce the magnetic field. Select a point P. Say for example P is a point, and this P is at a distance of, this point P is at a distance of what? R from this current carrying conductor. So here is the current carrying conductor of almost infinite length here. P is a point which is at a distance R from our current carrying conductor, and that point P we want to determine the magnetic field. So what is the procedure to find the magnetic field by using Ampere circuital law? What procedure we are going to follow? The simplest procedure we are following, if we want to determine the magnetic field produced by any current carrying conductor at a given point, the first step we have to draw a circular imaginary loop, and that loop should pass through our point. ನೀವು ಯಾವ ಪಾಯಿಂಟ್ ನಲ್ಲಿ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಅನ್ನು ಡಿಟರ್ಮೈನ್ ಮಾಡೋದಿದೆ, ಆ ಪಾಯಿಂಟ್ ಮೇಲೆ ಪಾಸ್ ಆಗುವಂತ ಒಂದು ಇಮ್ಯಾಜಿನರಿ ಲೂಪ್ ಅನ್ನ ಕನ್ಸಿಡರ್ ಮಾಡ್ಕೋಬೇಕು. ಅಂಡ್ ದಟ್ ಇಮ್ಯಾಜಿನರಿ ಲೂಪ್ ವಾಟ್ ವಿ ಆರ್ ಟೇಕಿಂಗ್ ಅರೌಂಡ್ ಕರೆಂಟ್ ಕ್ಯಾರಿಂಗ್ ಕಂಡಕ್ಟರ್, that imaginary loop will call it as a Amperian loop. ಈ ಕರೆಂಟ್ ಕ್ಯಾರಿಂಗ್ ಕಂಡಕ್ಟರ್ ಸುತ್ತಮುತ್ತ ಸಿಮೆಟ್ರಿಕ್ ಇರುವಂತ ಒಂದು ಇಮ್ಯಾಜಿನರಿ ಲೂಪ್ ಅನ್ನ ಕನ್ಸಿಡರ್ ಮಾಡ್ಕೋತೀವಿ. ಆ ಲೂಪ್ ಅನ್ನ ಜನರಲಿ ಏನಂತ ಕರೀತಾರೆ ಹೇಳ್ರಿ? Amperian loop ಅಂತ ಕರೀತೀವಿ. That loop will call it as an Amperian loop. Condition is that Amperian loop should pass through your point. At what point you are determining the magnetic field, ಆ ಪಾಯಿಂಟ್ ಮ್ಯಾಲಿಂದ ಆ ಆಂಪಿಯರಿಯನ್ ಲೂಪ್ ಪಾಸ್ ಆಗ್ತಿರಬೇಕು. Say for example, P is a point at which we are determining the magnetic field. I am going to imagine a circular loop around current carrying conductor. This is the circular loop around current carrying conductor, and that circular loop is passing through our point. ಇದು imaginary loop actually. ಈ imaginary loop ಏನಂತ ಕರಿತೀವಿ ನಾವು? Amperian loop ಅಂತ ಕರಿತೀವಿ. It is called what? Amperian loop. Okay, this is the first step. And of course, this loop is symmetric to our current carrying conductor. ಅಂದ್ರೆ ಅರ್ಥ ಏನು? All the points of this loop are at same distance from our current carrying conductor. Same distance around current carrying conductor. ನಾ ಏನ್ ಮಾಡ್ತೀನಿ ಅಂತಂದ್ರೆ, this Amperian loop ಅನ್ನ number of small segments ಆಗಿ ಡಿವೈಡ್ ಮಾಡ್ಕೊಳ್ಳೋಣ. Will divide this Amperian loop into number of small segments, each of length dl. ಇದು ಒಂದು ಪಾರ್ಟ್ ಅಂತ ತಗೊಳ್ರಿ. Consider one more part here. Consider one more part. Each part should have the length what? dl. Each part what I am considering length is dl, and B is a magnetic field at that dl. ಯಾವ dl ನ ತಗೋತಿದ್ದೀರಿ, ಯಾವ ಸ್ಮಾಲ್ ಪಾರ್ಟ್ ಅನ್ನ ತಗೋತಾ ಇದ್ದೀರಿ, ಆ ಸ್ಮಾಲ್ ಪಾರ್ಟ್ ನಲ್ಲಿ ಈ ಕಂಡಕ್ಟರ್ದು ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಎಷ್ಟಿರುತ್ತೆ ಹೇಳಿ? ದ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಅಟ್ ದಿಸ್ ಪಾಯಿಂಟ್ ಡೆಫಿನೆಟ್ಲಿ ಇಟ್ ವಿಲ್ ಬಿ ಬಿ ಇರುತ್ತೆ. ಓಕೆನಾ? ನಾವು ಎಂಟೈರ್ ಲೂಪ್ ತಗೊಳ್ಳೋ ಬದಲಾಗಿ ಒಂದು ಸ್ಮಾಲ್ ಪಾರ್ಟ್ ಅನ್ನ ತಗೊಳ್ಳೋಣ. ಆ ಸ್ಮಾಲ್ ಪಾರ್ಟ್ ಲೆಂತ್ ಏನಿರಲಿ, ಡಿ ಎಲ್ ಇರಲಿ. ಆ ಡಿ ಎಲ್ ನಲ್ಲಿ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಎಷ್ಟಿರುತ್ತೆ ಹೇಳಿ? ಬಿ ಇರುತ್ತೆ. ಬಿಕಾಸ್ ವಾಟ್ ಎವರ್ ದ parts you consider, all parts are at what? Same distance from the current carrying conductor. Therefore, everywhere on this loop, the magnetic field will be constant. ನೀವು ಯಾವುದೇ ಪಾರ್ಟ್ ತಗೊಳ್ರಿ ಈ ಲೂಪ್ ನಲ್ಲಿ ಎಲ್ಲಾ ಕಡೆನೂ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಏನಿರುತ್ತೆ? ಕಾನ್ಸ್ಟೆಂಟ್ ಇರಲಿಕ್ಕೆ ಬೇಕು. ಬಿಕಾಸ್ ಆಲ್ ದ ಪಾಯಿಂಟ್ಸ್ ಆಫ್ ದಿಸ್ ಲೂಪ್ ಆರ್ ಎಟ್ ವಾಟ್? ಸೇಮ್ ಡಿಸ್ಟೆನ್ಸ್. ಈಗ ಏನ್ ಮಾಡೋಣ ಅಂದ್ರೆ, ಏನ್ ಸ್ಮಾಲ್ ಪಾರ್ಟ್ ತಗೊಂಡಿದ್ದೀರಲ್ಲ, ವಾಟ್ ಎವರ್ ದ ಸ್ಮಾಲ್ ಪಾಯಿಂಟ್ ಯು ಹ್ಯಾವ್ ಟೇಕನ್, find B dot dl. Find the B dot dl. That is dot product of what? Magnetic field and dl. And sum, or take the sum of all such B dot dls. ಮತ್ತೊಂದು dl ತಗೊಳ್ಳೋಣ. We'll find the value of B dot dl. Consider one more dl. Find the value of B dot dl. Consider one more dl. Find the value of B dot dl. Later we'll take sum of all the B dot dls. In complete Ampere loop nalli we'll consider the sum of all B dot dls. That sum can be determined by which method? Integration method. Therefore what I can write? Integration of B dot dl. Integration of B dot dl, or sum of all B dot dls over any closed loop. Over any closed loop is always equals to mu naught times current enclosed by that loop. Mu naught times the current enclosed by that loop. The total sum of B dot dl. The total sum of B dot dl over any closed loop or over any closed Amperian loop should be equals to mu naught times current enclosed by that loop. And this is called the statement of what? The Ampere's circuital law. What is the statement of the Ampere circuital law? Integration of B dot dl is equals to mu naught times I here. This is the mathematical form of what? The Ampere circuital law. Then how we are framing the statement here? What is the statement? It is statement integral of B dot dl Generally we will call it as a line integral. ಇದನ್ನ line integral ಅಂತ ಕರಿತೀವಿ. Line integral of b dot dl over any closed loop. Line integral of b dot dl over any closed loop is equals to mu naught times current enclosed by that loop. ಇಲ್ಲಿ statement ಬರೋಣ. I will write the statement at the top here. What is the statement? Line integral of b dot dl over any closed loop is mu naught times current enclosed by that loop. This is the statement of what? The Ampere's circuital law. As I said you, the main purpose of the Ampere circuital law is to determine the magnetic field produced by this conductor at this point. ಈ ಕಂಡಕ್ಟರ್ದು ನಾವು ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಅನ್ನು ಫೈಂಡ್ ಔಟ್ ಮಾಡೋಣ. ಯಾವ ಪಾಯಿಂಟ್ ನಲ್ಲಿ? ಪಾಯಿಂಟ್ ಪಿ ನಲ್ಲಿ. ನಾನು ಮೊದಲೇ ಹೇಳಿದೆ, in order to find the magnetic field produced by this infinitely long conductor carrying the current, you have to imagine a closed loop, and that closed loop will call it as an Amperian loop here. That closed loop will call it as an Amperian loop here. So of course, in which I am taking a small part dl, and at that dl the magnetic field is B. Will you tell me what is the direction of the dl? So the direction of the dl is along this direction. This is the direction of the dl. Then what is the direction of the magnetic field? As per right hand clasp rule, the direction of the magnetic field is along the tangent to this loop. ಈ ಲೂಪ್ ಗೆ ಟ್ಯಾಂಜೆನ್ಷಿಯಲ್ ಡೈರೆಕ್ಷನ್ ನಲ್ಲಿ ಇರುತ್ತೆ. ಅಂದ್ರೆ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಡೈರೆಕ್ಷನ್ ಕೂಡ ಇದೇ ಡೈರೆಕ್ಷನ್ ನಲ್ಲಿ ಇರುತ್ತೆ. ಸೊ ದಿಸ್ ಈಸ್ ದ ಡೈರೆಕ್ಷನ್ ಆಫ್ ದ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್. ಬೇಕಾದ್ರೆ ಇಲ್ಲೊಂದು ಡಿಎಲ್ ತಗೊಳ್ರಿ ನೀವು. ಇಫ್ ಯು ಕನ್ಸಿಡರ್ ಒನ್ ಮೋರ್ ಡಿಎಲ್ ಹಿಯರ್, say for example this is dl and this is the direction of what? dl, and this is the direction of what? The magnetic field. So the magnetic field and dl both are in what? Same direction. Both are in what? The same direction. So by having that knowledge, let me determine what is the strength of the magnetic field. For that I will consider the statement of the Ampere circuital. What is the statement of the Ampere circuital law here? Line integral of b dot dl is equals to mu naught times I here. That is the statement of what? Ampere circuital law. Okay. Further, line integral b dot dl can be written as what? B dl cos theta. From the knowledge of dot product, a dot b can be written as what? A dot b in beritil. A dot b can be written as what? AB cos theta. A dot b can be written as AB cos theta. Similar way, b dot dl can be written as B dl cos theta, which is equals to what? Mu naught times I here. What is theta? Theta is the angle between B and dl. The theta is the angle between B and dl. Here from the diagram, B and dl both are in the same direction. Therefore, the angle between B and dl is 0. In general, B and dl are parallel to each other. What I can write now? Since B is parallel to what? dl, therefore the value of theta is equals to 0. This implies, what is the value of cos theta? Theta 0 ittandre cos theta value ಎಷ್ಟು ಇರುತ್ತೆ? 1, because cos 0 is 1. Substitute here. Therefore, the integration of b dl, the value of cos theta is equals to 1, which is equals to what? Mu naught into I here. Okay. B is constant. I will take outside the integration. I left with integration of what? dl is equals to mu naught into I. Okay. So if we consider only one part, this is called dl. If we consider another part, 2dl, 3dl, 4dl, 5dl, 6dl, ndl. What is summation of dl is called? Summation of dl is nothing but sum of all the dl's over closed loop, which should be equal to length of this loop. So summation integration of dl atandre it is sum of all the dl's. Sum of all the dl's. That sum of dl's should be equal to what? Length of this loop irutte. Andre artha enu? Since what I can write now, summation of dl should be equals to 2 pi r likkebeku. Summation of dl should be equals to 2 pi r. If summation of dl is equals to 2 pi r, substitute there. What I can write now? B as it is. Summation of dl is how much here? 2 pi r, which is equals to what? Mu naught times I here. Mu naught times I. Then what is B? B can be written as mu naught transfer 2 pi this side divided by 2 pi into I divided by R, which is an expression for the magnetic field. So this is the expression for the magnetic field produced by infinitely long current carrying conductor using Ampere's circuital law. Statement ಬರಿಬೇಕು ನಮಗೆ. Statement ಬರೆದಾದ್ಮೇಲೆ magnetic field ಅನ್ನು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ತೀರಿ. What is the statement here? Line integral of B dot dl over any closed loop is mu naught times current enclosed by the loop. Then in order to find the magnetic field produced by what? Infinitely long conductor at a point P, we are going to imagine a circular loop, and that loop will call it as an Amperean loop, and then we are performing some simple calculations in order to determine the magnetic field. Okay.